First of all, we would like to introduce ourselves. We're here together with Wouter van den Bos, who is CEO of SDC Verifier. Also, Jarko Jurečko is going to make a demonstration of the software itself, and I will make a short introduction into the SDC Verifier and what is this software and how it's going to work in your engineering routine. So first of all, I would like to show you the agenda of this meeting. I will try to keep my introduction to the SDC Verifier as short as possible and give a bit more time for Jarko to do the demonstrations. But first of all, I will make 10-15 minutes introduction and show you the software possibilities. Then Jarko will show you the calculation cores, the recognition tools, how do we check according to standards, how to start the calculation procedure, and reporting features if we will have enough time, and then we will have Q&A session. But if you have any questions during the meeting, you can unmute your microphone because microphones are muted by default. You can unmute your microphone, or you can type it into the message box and we will respond when we see this message. So SDC Verifier is the add-on to Ansys, which is built on top of Ansys and is built for helping you to do the code checking within your Ansys model. We have implemented the load combination tools, the recognition of structural members, because all the checks are done on the structural items such as beam members, plates, or welds, and not on the finite elements. Then we have a lot of popular standards already prescribed and already implemented in our software, and we are constantly growing this database and we are adding new standards. And of course, you can write your own checks, and the extensive reporting feature, which includes the description of how your model is built and the result of your calculation. This webinar will be mostly describing the process of recognition of the welds and the weld checks and fatigue calculation on plate model. On the 3rd of July, we're going to make another one, which is more focused on the beam elements and checks of the beams and joints and beam buckling. So I will send you invitation to that one as well later after this meeting.
I just wanted to say that 3rd of July, because the 4th of July is a holiday here, big holiday, most people are going to be gone for vacation in the United States. So 3rd of July is I would probably schedule either the week before or maybe like 2 weeks after, because a lot of people are going to be gone.
Okay,
that week or the week following.
This is a great suggestion. Yeah, we didn't take it into account. We probably then we're going to move. I think we already for the morning we already made the announcement. So probably morning one for Asia will be done on the 3rd of July, but the evening one for United States we're probably going to move to the next week. Thank you very much. Okay. Let's go back to the window of the SDC Verifier. So SDC Verifier is implemented into your workbench. You can see it on top of your model, and for now it is built as the separate window, which looks like this, with the model tree, with jobs, recognition tools, standards, report, and all this things Jarko will show. But we will also mention that we're now working with Ansys to make it completely integrated within the Ansys software. So in the nearest versions, we will have this implemented in the workbench as well. This is how the workflow of SDC Verifier look like. We take your finite element model, we do all the load combinations which are required for the code checking. We do the recognition of structural members, we do the code checking and formulas, and then we have the automatic report, automatic documentation. And the biggest benefit of the software is that the whole calculation procedure is stored, so you don't need to repeat this if you want to do the same calculation template for another model, or if you have the late design change, or if you need to track your changes in your model. So you are able to open the calculation procedure as a template and the report as well, quickly update the analysis and generate the same template document for different models or for different types of structures. First of all, we're going to review the load combination. So many standards are having complicated load combinations to be implemented for checking. There is some regular loads, there is some occasional loads, exceptional loads with certain partial load factors and with safety factor to be put it on. So we are able to create this combinations easily. We are able to create this pattern in our own software, or you can upload it from Excel or export it to Excel to edit and store separately, and then we're able to present the results for different combinations and also the groups. Now I will show you how it's implemented into the software. So we have the structure of the calculation like this. We have the individual load, which is single load result. Then we have the load set, which is linear combination of loads with already with some partial factors. And then we have the load group, which is an envelope set of results. Load group can contain load sets or individual loads or both of them, or even load groups. So you can make group of groups or group of load set and show the envelope result for this load group, so see the overall maximum. Of course, if you have created the huge amount of different loads, you need to handle this somehow, and you need to understand what's happening with your structure and what is the most crucial or governing loads for your finite element model. So we have created some tools which are helping to handle your loads and to understand what's happening. For example, we have a governing load tool which is creating a plot highlighting the most crucial load sets for your model. So for example, you select stresses or utilization factor for standard as a parameter to be plotted, and then you're able to see that here on the tip you have area painted with green, which means the highest results of this parameter appears due to loads set 70. So load combination number 70 is causing the biggest stresses here. So red one is load set 6, which is causing the problems in this area, or the highest results in this area. So this helps you to reduce, for example, here we had 132 load sets, to reduce the amount of this load cases into 8 or 9 as here, and to show which are the most crucial for your model. Sometimes you have extremely big models which can contain millions of finite elements, and you can easily miss the peak or miss the highest results. So we have the peak finder tool, which helps to recognize the worst results over selection, which helps to show, for example, you're able to show all the values above certain number, like here it's shown all the utilization factor values above 1, but you can also highlight 10 worst results or 5% of worst results, which helps you to never miss the hotspot on your model. So this is extremely brief overview of load combinations and load handling tools, and now we're going to the recognition section, where I will show you which type of structural members we are able to recognize. First of all, we are able to recognize the sections. On this example, you can see the ship. We can recognize the frames, decks, and longitudinals of the ship, and after that use this to do the more deep recognition of the plates. And the biggest benefit that is that it's mesh independent, so no matter how many finite elements you have here, is it one element or is it 100 elements, we will recognize this plate, we will recognize its dimensions, and in the future it can be used for the plate buckling checks. We can also recognize the joints, the type of joint, the direction of the connection. like 1D joint here or 3D joint here, and also you can see in which direction we have the connection. Why do we need that? We need this for buckling lengths and for joint checks. Regarding the buckling lengths, it's extremely important to have the correct value. It's important to understand if you have the joint in Y direction, for example, as here, or you have the joint in Z direction, that completely changes your buckling length. So for buckling in Y direction, we will have two members by for 3 meters, and in Z direction we are going to have one member 6 meter long. Then this is a slide which shows you how the recognition is done. So you have finite element model with a lot of elements, and in the end it is recognized, and you can see the separate beam members and joints. Next one is the possibility to recognize the welds, which will be shown today by Jarko. We are able to find the welds, the welded connections on your model, and convert stresses in these welds into weld direction. So we can recognize the weld the stresses parallel to the weld and then perpendicular to the weld. We can also see the weld intersections, weld tips, and we are able to set some exceptions. For example, if you have the I-beams which are rolled, so you don't need to have this welds here at the flange, you can set the exceptions, and in this case you will have welded connections only where you have the weld in reality. So now we proceed to the checks. All this recognition was required to perform the checks. For example, the slides show you which standards we have already implemented. This is only part of them, and as I mentioned, this database is growing, and we're constantly improving it. For BIM members, we have AISC, API, Eurocode checks, NORSOC, and so on. So the recognition of BIM members is used for BIM member checks. For fatigue, it's extremely important to recognize the weld and set the weld classification. For FEM, DIN, and Eurocode 3, and in this version, on this Monday, we released the version 5.2, where we have EN 13001 as well. And then recognition of sections and plates is important to have the correct results for your plate buckling checks according to DNV or ABS. This is how the check window look like. So we have the formulas, which is easy to build, which is simple, and the logic is close to Excel or math lab programs where you have to create the formulas, but what is the benefit here? That you can create the formulas using the result of your calculation or properties from your model as variables for this formula. So all the checks of our program are open. So you can take a look. You can even copy this as template and write your own checks with some change safety factors or some changed rules. Of course, it's not going to be called AISC anymore, but it will be called like a custom check based on AISC rules. This is the easy example, short example, how do we build these formulas. For example, we need to perform a quick static stress check with safety factors prescribed by a standard. So we create a parameter material yield, which reads the yield from your model. We create the allowable stress parameter, where we divide this value of yield by a safety factor. Here you can see that it's different for different direction. It's 1.67 for all direction, but then it's overwritten for shears into 2.5, and then the equivalent one is 1.43, and we divide the stress on your element by allowable stress, which we just created, and we receive the utilization factor parameter, which we after this can use for plots and table. And if this value is above 1, it's not passing the check. If the value is below 1, it's passing the rules of the standard. This slide shows you how the result of plate buckling calculation are done. So we recognized the plates as I showed before, and then you can create plots and tables with highlighting the results over these plates. Are they passing the rules of plate buckling standard or not? And it can also be shown in table like this with the value of the buckling. Then we have the fatigue check. For fatigue check, you have to fill in certain parameters like the amount of cycles or classification of welds. You can set the classification for the full models and overwrite the welds with K1 for direction along the weld, and then K3 perpendicular to the weld. Set a separate classification for shear and weld intersections, which are separately recognized. You can also set the different classification for the intersection of the welds. For fatigue, we use Palmgren minor rules and Ansys method, and this is the example of the fatigue calculation we've done recently. The idea is that this was under some kind of double roof, and this area was missed, and we did the calculation and highlighted this point to the inspection guys, and during the next inspection they reached this point and actually found the 30 centimeters crack in this area. We also are able to recognize the welded and non-welded plates and then do the check of welds over the length. So we summarize the force over the full weld, and then we are able to do the check and calculate if the weld is strong enough. I think Jarko will show this one as well. And if in your model beam bolted connections or riveted connections are modeled with beams, we can also perform the rivet check and or bolt check and check the shear or axial shear and axial force and slip resistance, and highlight even the bolt which is going to fail first. This is the brief overview of checks, and the last chapter of my report is automatic documentation. The software has a powerful tool to create the automatic reports, which are built with some template, and you are able to export these reports into Word document, PDF file, or PowerPoint presentation, and you're able to describe how your model is built, what are the properties used, what are the materials, where do you apply the loads, and what are the loads values, what are the constraints, and then describe the calculation results and check results with plots and tables, and set, for example, one template for one load combination or individual load, and then copy this to the complete structure of the document. So no matter how many loads do you have, you will have a huge document which is describing the results of the calculation, and it is easy to navigate through this document. So for example, you have created the calculation report which describes this is the part of the model setup. So what is the property used, what is the yield, tensile, and where is it actually located. Then in other chapter you show the actual result on this model, and tables are showing values which you set, or its stresses or reaction forces, displacement, utilization factors of standards of code checks, and the plots as well. And then you can easily navigate through this document using the bookmarks. So no matter how many loads you have, you can click on the bookmark and check it out. So it's easy to read these reports. So the main benefits of SDC Verifier software is that it enables the code checking in your finite element program in Ansys. So you don't need to use some dedicated software to build another model to do the code checking. You have your model for the calculation, and you use this for code checking as well. We have a lot of popular standards available, and it's customizable, and you can write your own. And then we have the biggest benefit is that the calculation procedure is saved and can be opened as template or stored, because if you have some last minute design changed, it's just 2 clicks to update the model, recalculate, and then generate the new report. And the report is extremely extensive document which shows all the setup of your model and the results of the calculation, and it's generated completely automatically. Now I will show you a few slides with how can we proceed and what are the possibilities for you to try the software and verify and learn how to use it. We have the trial license available, so you need to have this trial license, you need to download the software and go to the Help and License Manager, and here request the trial, fill in your data and press send, and we will send you the trial license file by email, and it's valid for 15 days. We have a lot of step-by-step tutorials on our website, where you have the PDF file with steps you need to follow to do certain things like prepare the report or do the Eurocode fatigue and so on. And there you have some test models and test SDC Verifier files. And on our YouTube channel you have some videos with tips and tricks how to do certain things like find the welds or combine the loads. And the webinars are also recorded and stored in here, so you can take a look on that later. We also provide the live training in your office, so we usually come to your office for 2 days and help you to get used to SDC Verifier, to understand how it works and how it can help you in your engineering process. And as I already mentioned, we are going to have the next webinar on beam structures. It's not going to be held on 3rd of July then. We will move this, I think, one week later, but that will be later agreed and I will keep you informed. And that's it for my part. You can always contact me or find us by these emails or call us to our help desk or our mobile phone, and we are able to well, we will do our best to help you with your problems if you have some, or solve your questions. And if you have any questions regarding my part, I can respond to this right now, or we will proceed to the demonstration with Jarko.
Yeah, I have a couple of questions.
Okay.
One second, I'm just finishing writing them down because okay. One of the first ones was about, I know we've brought this up multiple times, but the interface and the plotting specifically. Have you guys made progress on changing the capabilities there in terms of, I think we had a report from India that they wanted a certain plot types, values shown on there, like, down at an element level rather than just at a beam level, for utilizations. Another thing, we'd like to have multiple plots available. For example, in Workbench, right, I can have 20 different plots ready to go that I do a post-processing on. Okay, I want a surface von Mises, I want a mid-plane, I want displacement, I want this, I want that. And in SDC Verifier, when I click on a plot, it generates one plot inside of Ansys, one plot that says SDC Verifier, and when I try to generate the next one, then it erases the first and does the next one. It just makes it a real pain to gather those together. That's the first question. Have you guys made any progress on those?
Yeah, that is hi. This is Jarko. So we did the possibility to make a duplicated plot if you want. First, we wanted to make that each plot is created separately in mechanical, but when you generate report, it also can follow the same logic, so it can be a bit of the mess. So we added the possibility that you can duplicate the plot and it will stay in mechanical. But actually, we are working on integration, as I show you in the end, because Ansys guys made some progress on ACT, which opens for us some possibilities. We started to do integration. We have but that will be in Ansys 2019 R2, I think, because there they did some improvements. So for now, there are improvements on plots speed and performance. So we did some improvements, Ansys did, so it works better. I understand that question about the main idea is that SDC should be inside, but that will take some time to change that, and then probably we will try to do similar logic, more similar logic to Ansys, that you can define, create plots as it is in mechanical. So this is planned for this year. I hope till the end of the summer, but maybe a bit later.
Okay. The second question I had was about the beam connections. So you did talk about when you have I-beams coming together, weld recognition. But in the plots that I saw, you know, on the model plots, you do have areas. So when you have two I-beams coming together, right, one is welded to the other one, it seems like in the plots, you still have elements from both beams overlapping, right? So basically, I guess this is a question about the offset issue. Have you come up with something, or does the weld checks, does that take care of that? Does that you know, consider those elements that are kind of overlapping from one beam to the other, since they're, you know, connected at a node? Does that consider those separately, or, you know, how have you dealt with it, I guess, since the last time we talked?
Yeah, it's a bit of it's not the main topic of today, because today we talk about plate models and welds in there, while all your questions are related to beam models and beam connections. So if you have a beam, we we cannot recognize welds because there are no welds in the model as such. You can use the direct stresses of the element instead. And maybe we will, if you write down these questions, then we can take these into account in the next webinar, which is focused specifically on this topic.
Okay, just some of the graphics you had up seemed like that's what you had beams up there with welds, or maybe you just did model the beam as extracted plates connected together. Maybe that was what I saw.
Yeah, I think it was beam modeled was plates. Yeah.
Yeah, because if you use the plate representation, you can do all the stuff you are going to see today.
Right.
So if you want to do a real connection check with the weld and a correct distribution of the loading, it is better to model the joint as plates.
Right.
Anyway, because with a beam, that is never an exact or good representation.
Right,
So
because you have the overlap at the nodes. Yeah. Okay.
Yeah.
So, sorry, when you do these extractions, when you do a beam as a combination of plates, do we need to basically make the model twice to then do a beam analysis?
If you want to do the beam check, you need to use the beam representation, and the parts where you want to do the joint, you make a small separate, a double representation.
Okay.
So for now, yes, but we are working on, because you're not the only one requesting that, working on also do beam checks directly on plate models. But that's going to take a bit more time, because that, as you can imagine, is slightly more complicated. But we will get there.
Right. Okay.
Yeah.
Yep, those were the main questions.
Okay. Then my presentation took slightly more time, so I would like to give the floor to Jarkko, and he will show the demonstration how to perform the checks. Thank you.
So, Alec, let me know when you see my screen.
Okay, not yet. Yes, now I see your screen.
So I'm going to start for explaining my model a bit, because it's important to understand the logic of SDC of combination, groups, envelopes, and fatigue. So, but first, how do you create an SDC project? So when you install an extension, it appears in Workbench under the Code Checking and Reporting tab. SDC Verifier, so you need to simply drag and drop it in on your model. I already did that, so I have prepared two projects. One is empty project where I need to define everything, and the second project is all the results to save some time on calculations for all projects. So I will go with empty project, show you all configuration, and then in the end we switch to the final project which has all results and see some plots, results, and in the end we will see some features of the report. It depends how much time we have, so or it will be very brief, or we can see more. So to start SDC, you double click on the item in Workbench project theme. It connects automatically to mechanical. So as you can see, I already have 3 projects saved. So I will go with start. And SDC automatically connects to the Workbench, read all the data, materials, properties, boundary condition, and also the results. So as you can see, I have static analysis with 17 steps in my model. So I have support. This is support structure with I'll show you on the presentation with 2 sides, and on each side I have 8 support points. So it is constrained from on the corners. So we go back to mechanical. So SDC use individual loads, and it's important to understand how we treat them. In mechanical, you have steps, which gives you results, and SDC treats each step as individual loads. So in my model, I have 17 individual loads, which represent 17 results in mechanical. So I want to show you that on my scheme. So we have applied on each support position on the left side and on the right side 250 kilonewtons. So from first position to fourth, it is 250 positive direction vertical. From position, it should be from position 5 to 8, it is negative direction 250. It's left side, and on the right side we did the same. And also have one step where I have all the forces applied together on the negative Z direction. So I have 17 results, and based on that I'm going to show how we do load combinations in SDC Verifier. So we have a tool which is similar to an Excel table where you create a lot of load combination at once, so 10, and you can paste factors here or copy that from Excel. Or I have prepared my combination in Excel, so I have a table here. For simplicity, I used only 4 combinations, but you can do as many as you want. SDC Verifier is not limited in combinations. So I just simply press from clipboard button, and the data copied from Excel appears here. When I press OK, it is created in SDC. You can see it in trees. So I did a combination of position 1 with 5th position, with forces on all position in minus Z direction, and same for the right side. So we also add a function. If you want, you can export those combinations back to mechanical. So we have functions which are on the load sets menu, which is export to mechanical. And I want to show you an example. For example, load set 1. What SDC does, it makes a copy for your existing solution. It copies all the forces, but it rearranged the tabular data where you define values for your forces. So I had 17 steps, but I had 4 load combinations. So it creates a copy with all loads, create 4 steps, and multiply values of forces on factors defined in SDC. So in my cases, it's 1, as you can see. Here I showed an example how it was done for first load combination. And then you can run analysis if you want, some dynamic analysis in Ansys back. So that if you use different factors, you can use 1.2 minus 1.5, you can make different combination, and they can be exported back. When you did a lot of combinations, we have the item which calls load group, which is an envelope. We use that to quickly estimate all your results. If you make a plot or table for envelope, you get the minimum maximum results for all your items added to the envelope. In my case, I'm going to create an envelope. which contains all my weld combinations. So if when I mentioned this, you can create how many you want weld combinations. If you create 400 combinations, you still can create one envelope, and you still can make one plot to estimate your results. Also for fatigue, you need to do one extra step, because we need to know stress history. Load groups is used as a stress range, and then fatigue group you need to define. For each stress range you want to check the amount of cycles. For this demo I'm going to use, that's my stress range is working for 500,000 cycles. And basically first step we have done. We have imported results, we made it combinations, we made one envelope for quick estimation, and we also prepared the fatigue group for fatigue calculation. You can create more groups to get the stress ranges and create much more complicated stress history for your fatigue calculations. Now we are ready for the second step. Now we can do recognition. In the menu we have the recognition, where you can see we have 4 different tools. We are going to start today from Weld Finder. So what you need to do, you need to press Find Welds and wait a couple of seconds. So for the model which has 50,000 of elements, it's a couple of seconds to analyze the model, and then you get the list of welds. Then the first thing what you can do, you can preview your weld in your model. So you press the button Highlight, and then in Mechanical, it highlights all elements which are recognized as welds. Now I want to show you, because for weld strength check, what we are going to see today, you have to also make a distinguish between the elements which are welded and non-welded, because you need to set classification for welded parts elements. And when we have a feature where you make a plot which will show you with different colors what elements are welded and non-welded. So basically you can see that we put 2 labels, which shows you blue elements are welded in your structure and yellow is not welded. Okay, and after we have checked our welds, what was recognized, we need to go and set up the classification. You need to set up the type of your weld. It can be double full penetration, double partial penetration, or double fillet weld, and dimensions of your throat thickness or other dimensions depend on the type. So for the simplicity, to make it quick, I will set the double fillet weld for all my welds, and I have, as you can see, all of them are pretty thick. It's 40 millimeters, but I don't want to put that big welds, so I will start with throat thickness of 10 millimeters and apply to all. The program says that I'm going to change 824 welds. I should to confirm, and then I have the type. So it's not necessary to apply to them all. We have a filter window here to make a classification quicker. So what you can do, you can, for example, pick the elements from the model if you want. So we go to Mechanical. I can click on few elements, for example, press yes, and if I say apply filter, it shows me only elements that I have chosen in my selector. I can preview it. So it's enough to click on one element to pick the part, welded part, from the weld. Besides that, you can also show based on type, based on length, so you have some filter which type you want to see, or the thickness parameter with some conditions. So you quickly can make some groups of welds that you want to change and to define the values. After you did that, so you can close the recognition of welds. It's ready to be calculated. And later we will go for creating standard, but since this is nice model, we want to also to make a for this model, it shouldn't be a problem, the plate buckling, but for the demonstration, we want to do it because it's quick, it's not that hard to set up in SDC as well. So we go to Panel Finder tool, which makes recognition of buckling fields with the dimensions, and I will press Find All button, which will recognize sections in X, Y, and Z direction, and also the section which does not fit in those three planes will go to custom sections. So it's done. So we can, to do the same, we have all the preview feature as in the Weld Finder tool. So you can see that that's the sections along the X-axis. You see, we have special plots to see the with colors of the plates that I'm going to show you. It's also possible to make, for now it's only colored plots of all your plates, so you can see if you are happy with how it is splitted. If not, you can do adjustments, same for Weld Finder and Panel Finder. User can modify everything from dimensions or splitting or joining the welds and plates. So it is possible also to see with dimensions, but I don't want to show you full model because it will be a bit messy, but one section is fine. So as you can see, we have one section, and in the middle there is a length and width dimension of this green plate. So it's 1 meter 65 centimeters, 1 meter 32 centimeters. And if we want, we can go here and change that manually, as I mentioned, and user has full control. So after you did a recognition, you visually inspect if everything is done as expected. If necessary, you do some changes. If not, you close the recognition and you go to the check part. So recognition was the second step of our demonstration. So the plates and welds are prepared, and now we have to define the standards what we want to calculate. So we have here a tree of implemented standards. They are grouped by classification societies. Today we are going to run Eurocode 3 checks, welds. If you run it, so you can see a window with input, which is required for standard to do. So as you can see, welds are already recognized, and here it is shown that 654 welds will be checked because our check supports double symmetric welds and also straight welds, not circular welds. So it filters that automatically. You have a button to see preview the welds, which will be calculated, or opposite, you can preview all not supported welds and will be skipped. So you can see in your model that's circular welds or welds that has not a straight, not double symmetric, they are not supported, they are excluded. So you can do that on the wizard. Then we have to define correlation factor. So it's in the input, you can see where it comes from the standard. In a presentation, I copied that table to show you. It depends on the material. So for the list, I have one material, and I'm going to use factor 1. But depends on the material, you fill in that data. And basically, safety factor gamma m is defined. It's constant. Then you press OK, and your standard is added. So if you want, you can edit standards in two ways. You can press edit button to bring it back the window with parameters, or you can do that in a tree. So the correlation parameter is here to edit. So all the data split on two parts, input and all the checks. For this check, we do a lot of calculation because weld strength checks are done based on not stresses, but we read interface forces, and we have a special tool which sum the forces convert into weld directions, and based on summed forces we calculate stresses for welds. All these checks performs the calculation of stresses. Why this important? Because for weld strength check, you want to skip the peaks which appears where you get that from finite element models. For fatigue, you cannot avoid it. You have to use stresses, but for weld strength check, it's better to do based on forces. As my colleague Oleg mentioned, you can open and see all the calculation as a formulas. So that is not a black box. So I'm going to add 2 more standards, and then we jump to and preview the results. So we do the same procedure for Eurocode 3 fatigue. We want to do. So it appears a wizard for Eurocode 3. Here we need to define the FAT class. The FAT class depends on the type of the welds you have in your model. Usually you find that in the appendix of the standard. There is a table with the classification where you take the FAT class. So for our model, I did few screen dumps from the standard and also how we do classification. What SDC has is this classification which allows you to define different FAT class for different directions. So for perpendicular to the weld, it's 80. For parallel to the welds, it's 100. For shear, you need to use 80. For elements that are not welds, 160. For elements that are not welds in shear direction, it should be 100. So SDC automatically converts stresses in that direction. So X is parallel direction in SDC, Y is perpendicular. So first what we do, we put 160 for full model. Then we define for full model, but shear direction, we want to put 100. For welds, we have a special button in the classification because it's usually used for fatigue, so you can use add all welds quickly. For welds, we want to define for 100 for parallel, 80 for perpendicular, and for shear as well 80. And we need to add one more rule. For weld intersection where 2 welds meets, we want in all directions to be the lowest FAT class, to be on the safe side. This is conservative. I will show you in a moment how it looks like, because after you set up your classification, you have to make a plot to make sure you did it correct. So you have a button plot here, and I want to see that in X direction first. So SDC will use this dedicated plot we have with colors and labels to show the fatigue classification. As you can see, its full model is 160, parallel to the weld is 100, and where 2 welds intersect, those are elements act perpendicular to both welds, so we need to use 80 for them. And if we plot, let's do one more plot for shear direction. Okay, for shear direction we have 100 for the full model and 80 for welds. So it seems to be correct. Then after we did the plots, those plots also can be included in the report as well. So we press OK. Then we have to define the stress range can be reduced for compression if your model is fully stress relieved. Here is a description. So usually for all the input, all the characteristic, we use the description from the standard, so you can read if you don't know something. So we keep it not reduced for this model. Then you have to define a safety factor for your model, which depends on consequence of failure and assessment method. So you can choose 2 options, which changes your safety factor. We keep it the default options, and we press OK. And the second standard is defined. So we do the same for the plate buckling, the latest standard, what we're going to do. So DNV, plate buckling 2010. For this standard, we have a safety factor. We decide what stress we wanted to use. We have special, for plate buckling stress, we have special conversion methods. What stresses we want to convert and use plate average stress. In SDC, you have a button to see an example how stresses are calculated. I'm not going to explain that in details today, but you can check that. And you choose what sections you want to analyze for your all sections that are recognized. I want to analyze. I press OK, and my standards are defined. So in this section, we have a windows where it helps user to define an extra input, which we cannot get from the model, which requires for standard calculation. And now we are going to the last step, see the results. And so we open the project where I have everything calculated. So what you need to do, usually you have the last check where you have the overall parameter. This is utilization factor overall, so it's maximum among all the checks, which is done in standard. So to perform the check, you have to press preview plot. And that if SDC used the legenda from 0 to 1.2 to scale, if your data, if your elements are orange or red, it means that it doesn't pass. So I can see in my model that I have locations where I have problems with my check. But to be sure, we have that the tool which calls Peak Finder, which is additional post-processing tool. I make a configuration that I want to see from this Ulocode's Weld Strength check that results which are above 1 I want to be listed in the table. So I prepare the table. So I press find and I see I have 6 zones with elements that has higher values than 1, and it shows me what caused by what load combination. What I can do, I can make also a plot to show them with labels on top of each zone. So as you can see, it showed me the welds, and as a label here is the highest value on that zone. I have 6 zones, and what is the nice feature of this? I have a button here, export to component. The component is the same, similar as in mechanical as name selection. So I press a button, I have a component, and then when you do design process, you can go back to your weld finder and filter. As I mentioned, you can easily find welds. So I'm open selection. I will pick the group which is found by beam member finder. I press OK, filter, and here I have the list of welds which do not pass my check, and now I can change them. I can increase throat thickness and run calculation again. So I'm not going to do that because it will, if I change the weld classification, results for also fatigue will be changed and cleared, but I can see here that it showed me the welds which do not pass here. But what I wanted to show, that it's easy to go back and get the selection of welds which should be changed and improved. So in design process, it should go like this. You do the check, you get the selection where it's wrong, you get back to Weld Finder, and you do the changes. So same we have with Eurocode 3 fatigue. So we have make a plot for fatigue damage, and we display that for fatigue group because rest checks we do for load group, our envelope, which gives you the highest results, and for fatigue group you need additional stress history, so you need to do calculation for fatigue group, and you can see that we have some problems with fatigue in some spots. It's okay, and with the plate buckling, so we need one more plot to check the plate buckling. For this model, shouldn't be a problem because we have very thick walls, 40 millimeters and 60 millimeters. So as we can see here, everything is fine. But we also can run the peak finder and for a plate backwind if we want. I'm going to show you another tool we use quite a lot. in our project. So we have governing loads too. There I set a configuration that I want to see the stresses above 320 megapascal to show all elements for that and show what loads are caused. So I press fill, so it finds me the 4 load sets has elements with value above that criteria, and I can make a plot in mechanical to see the what elements are caused by what load combination. So as you can see, all loads are shown with labels and with different colors. And if I want to see elements from with orange colors are corresponded to load set 4, and also it shows me labels four labels with highest value close to the elements of that load. So I can do that with the criteria, or I can do that the same picture I can make for the full model if it's interesting for me. So I did to show me the full model. And those tools, Peak Finder and Governing Loads, can be also included into the report. You can see distribution of stresses from different loads. Okay, and finally, after we did so, we need 3 plots and 2 tools to make some estimation of our results in SDC. We did a setup in 20 minutes. If you know how to configure SDT, it's not that hard. And now I'm going to go to report, show you few features of the report. So our report is quite customizable. You can add your comment sections, and in the latest version we also add that you can import even part of the Word report documents. Automatically our report can make a description of your model, so show your properties. For example, I will generate the beam property, so it highlights in your model where the beams are located, and also it shows all the characteristics of the profile, area, moment of inertia, the mass, which material is used, how many elements you have, and the radius of that. Also we can do the same for the shell property. So I have those elements which are highlighted has the property with 60 millimeters. Also, we can do the description of our loads. So I have loads where it's applied. It shows me the data from mechanical, and also tabular data is added automatically to the report, so you can see the boundary condition. So there's one part you can preview the description of your model, and another part you can preview all the results. So the plots we did, I want to show you, for example, the stress plot for our envelope. When you press generate, SDC goes to, displays that in mechanical and automatically insert into your report. Then you can export your report to the Word and PDF if you want. Few features about plots I will show. For example, if you want, you can configure and have plots from different orientation. So I make from first plot was from top, and second was from the bottom. You can see, if I want, I can go to mechanical, for example, if I'm interested in particular, so I can make here, I want to see my plot in report. I go to report, I create new views, and I can change in my report options that I want to use that view. I can regenerate that plot. So, and now it's different. So if I don't want to see the full model, it's also possible. We have a selector in SDC where you can easily, for example, say I want to see only elements from second property quite quickly, and change selection for my plot. And if I press regenerate, it's automatically for me updates the plot. So SDC has a lot of feature. I did it for few plots, but you can distribute that for all your load sets, all the results you have. You can copy that quickly between different results, so you can quickly set up your report with the results you want and copy between the loads. And same for the standards. The one thing I want to show you, you can include all the input you did, and also you can include the formulas which are in standard. So if you generate, it can be added into report with the name, formula, and the description. And in some description you have reference to the standard, so it can be added to your report in appendix if necessary. Because for some standards, yeah, it can be 200 or 300 formulas, can be too much. But the user has that possibility. So I think that's it with my demonstration. It's only briefly, because report we can show one more demonstration on 30 minutes, how you can customize. So I would like to make a conclusion that for the 30 minutes we set up our combinations envelope and fatigue group. We did recognition of weld and buckling plate fields. We added 3 standards. You saw it was a few options to define extra to do the calculations, and to estimate the results. You had to add 3 plots for each standard to do, and that took us around 30 minutes. So thank you for joining us for this webinar. So I think I will pass words to Oleg, and now it's time for questions if you have any.
Jarko, did you have a latest PowerPoint slide on improvements, which answers also the question on the plotting improvements?
Thanks for reminding me. This is we got the latest Ansys. Because we have released last week the version 5.2. It supports versions 2019 R1 release, and we already started to work with R2 version, where they added some possibilities. You can see new icons, new stuff, and there was improvement. So we are currently working on the integration part right now. It seems it works quite smoothly as expected. So we plan to finish that this year. That's it. It's completely mechanical without this outside window, except the report probably. But this window we plan to move there, here in the tree.
Okay, and maybe it's a good idea to send this generated report and send that to the attendees.
Okay.
I think that can be helpful.
Okay, I will do.
Yep, we're slightly over 1 hour, but if you have any remaining questions, you can ask them now. Otherwise, you can always ask by email, and we will share the recording of this webinar with you, as well as report and my slides too.
Yeah, and I see a comment on 2019 R2 that is released by Ansys, but we have not fully supported it, so we're working on this for now. So if that was your question, if you want to use revision 2, you need to wait a bit to get that included as well. And the other question is there any checks for solid elements? Yes, you have. The solid, any result, basically the checks are based on results you get from Ansys. So solid results, stress results can be used as well. Plate buckling and these kind of things is hard because plates we cannot recognize, but we can do, for example, fatigue analysis. We can recognize the welds, and if you put a thin sheet to the outer boundaries of your volumes, you can do fatigue checks on the surface as well. So in case you have fatigue cracks and in a solid model with welds in there, that is a good option to have. I think we will add a webinar on solid models somewhere at the end of the year or something. And the other question I see, fatigue checks, is it using nodal or elemental stresses? Everything we do is based on elemental stresses, so also the fatigue checks. And if you want to use the nodal results of the SDC Verifier results, you will get the average of the calculated elemental results on the node after calculation within SDC Verifier. Any more questions? I see somebody typing. You can also unmute your microphone and talk if you think that's better. Yeah, the question on circular welds, they are excluded now because they don't have a length. But if you can split a weld before, and then you can do the check also on a circular weld. So you have to split them, and then you can do the straight check. Yeah, any more questions left? Then I want to thank everybody for joining and for the attention. We will contact you if you have any further questions. We will send you this report. We will send you a link to the webinar where you can so you can share it with your colleagues or something. And yeah,
I had just one quick question. You know, when you were going through and, for example, you were doing the weld recognition and then, you know, weld stresses, you know, you view the plot, you get a table generated. Maybe I haven't seen it. Maybe it is there already as a feature or you're putting it in. But is there a way to simply output, like from that window, to just click, print to Word or Excel immediately there instead of going through the entire report and then having to put them to the report and then outputting the report to Word or Excel? Could we just do it directly from the table generation or the graph generation?
You have, yes, actually we have on every window.
Right.
You have here a window for plate buckling. You have a button export to Excel. It makes a table of the data.
Maybe you can just show it, Jarko.
Yeah. Okay.
If you have a window.
You need to start sharing your screen again because now it's
okay. I'm not presenting anymore. Okay. Moment. I was thinking I am still showing my screen.
And maybe Oleg, you need to share.
I already did. I already did. I don't know if it's visible.
I see something.
Yes.
Okay, when you open a table, all the data can be seen in tables here. So you can see all the calculations here. And you press that button to export. And then it was here in Excel. It automatically pops up in Excel. I can show you again.
Yeah. So, okay, it looks good. And the this is something that we brought up with the Ansys folks, I think, when we had the last joint meeting. But in terms of tutorials, not just for tutorials for you guys, but tutorials on kind of the interface between the tutorials on some of the extracted elements. For example, when we have combinations of extracted elements, we have pipes or beams, and we have plates, and we have for, you know, in our model we have a plate that connects over, you know, a group of I-beams. Do we have any sort of tutorials or guidelines on how to define the contacts for those in Ansys to make sure everything gets processed properly and also properly in SDC Verifier? Because what I've noticed is that, you know, for example, if you have a plate attaching to a joint, you know, welded on top of a joint of I-beams, and you do the extracted models, then when you're defining the connections between the plate and the beams, you get problems with overlapping boundary conditions because it's going to one beam, it's going to the other beam, but they're both connecting the same node, and you have some radius on the connections. You know, I don't know if you guys have talked to them about it at all. It's something I brought up in the last meeting.
We do have some guidelines and some examples how to do that. But if you, yeah, I think the best way is if you start using SDC Verifier, we have a 2 days course, and we can include easily this because yeah, you need to do it in a proper way. Otherwise, what Ansys, what your FEA model, it does not correctly predict what happens.
Right, and then the SDC doesn't correctly predict.
Yeah, so you want to have a correct model. But yeah, we definitely have some guidelines. We have a lot of different ways of doing that. And it's not very hard, and I think easy to work, but yeah, it's a bit quick to find an example now, but we will add one extra slide to this presentation and include that in the email, how you can do that.
Right. All right, thank you.
Okay, good. Well, thanks again for the attention. Any questions you pop up later, you can send us also by email. And you can also contact us if you want to know more, or if you want to get a trial version. We can definitely help you getting one. Okay, I think that's it. I think all the questions are answered, yeah. Okay.
Okay, thank you all for joining our webinar.
Thank you. Bye.
Okay.
Have a nice day. Bye.
Yep, bye.
Hi.